today?
Nothing. How did doing 1 through 7 go? Though?
They took so long.
It did
Really?
take a long
It
time.
took so long.
Just
How
like plotting all the points and well, it didn't take that long. It probably took 5
Well,
minutes.
like to draw the graphs, you had to like plug in each different point and like plot everything.
But most of them were easy enough. You could just do it in your head.
Some of them.
Or like some of them, like it was obvious, like the y equals 1 over x squared. I plugged one, I plugged the other one. I was like, oh, I know what this is gonna look like. So I just like hand drew the rest of it because I had already found the 2 intersection points.
Sure.
Some of them were easy. It's just like. I remember.
So the graphing is what took you a long time. Not
graphing?
necessarily the calculus.
No, it took me like
Computation.
35 minutes to do it. It didn't take.
So do all of it? Okay, that's good.
I guess it took me closer to an hour, but that's just because I wrote out every single step in it. Or
I didn't get 5 though. I was confused with 5.
5.
yeah, I wouldn't say that like they're overly hard. It just took me a bit.
Square root of 3x plus 1.
Did you ever get my narration? Did you? That?
Yeah, I got them from both of you.
Okay.
Yeah. So one thing you could do is find the intersection points. Obviously, you could just solve them, but you could also use a calculator for that. The calculator next to 5 lets you know you can be calculator active on that. So another thing you could do is you could just plot those in your TID4 and then have it find the intersection point for you.
Oh, I didn't think about that.
That would have been nice.
Yeah, so the ones that have a little calculator symbol, you can use a calculator on.
Well, I used the calculator, but I was confused what I was like. I figured out 7 is a calculator one, and like I plotted it, and I was like, oh, this makes sense.
Oh, 5 took
7,
so
you don't
long.
need a calculator, but 5 took.
Okay, 5 took me like 15 minutes to do. And the reason is because when you're trying to find the intercepts, you have this like wacky thing. And so you can't just factor it out to find them. You have to like plug it into the, what is it? Negative b plus or minus square root.
Formula.
Yeah, that. Because that'll give you the 2 points. So you had to like do the whole thing and then find which was positive and negative, and it took so long.
Yeah, I would just use a calculator on that one. And just graph them and then just be like, trace, and then it'll tell you the intersection points. There's a function on your calculator that lets you find the intersection point.
Oh, so then I would plug in.
So it'd be 0 is where they intersect. Well, kind of. That's just where your boundary is. 0. Okay. With the line x equals 0. That'll be your bottom bound.
Oh, and then I can trace. So. And you trace. So did you get 4.8? What was the intersection point on the right?
The intersection point on the right was 4.79128.
That's right. See.
I tried to do it a couple different ways, but the quadratic formula was the best, like the accurate, most accurate.
Yeah. So then you set it out.
Features. Oh, here we go. So you can also do alpha solve. I should put in. Oh, maybe I need to just put in. I'm trying to think. If I do second square root of 3x over plus 1 minus x, I should be able to just hit second solve. I'll have to figure out how to make that work. There's a solve feature on your calculator that you can use to just.
I found it in mine.
Yeah, it keeps giving the previous answer, but. Okay, there's options. You can either graph it and then have it trace the intersection, or you can just do it algebraically on the front screen too, but I'll have to find out the exact button order to make that work. But. Okay, you did find the correct bounds though, so then it's a pretty easy calculation from there, and you can really just have your calculator do it. Math 9, and then plug in those bounds, and then call good.
Square root of 3
Oh yeah, that's another thing that tripped me up. You had to put the square root of 3 at the front. I was confused.
Wait, so what did you get for your answer?
5.423.
Is that right?
I don't actually know. Wait, no, it's right. I checked.
5.423.
Because you can check it with this thing. Math 9.
Yeah, just use Math 9 and solve it. Don't even do it by hand. Because that one says it was calculator active.
Oh, okay.
Yeah.
It's a bit.
That makes sense though.
Okay. Good. All right. I keep trying to check my phone to like see my itinerary for the day, and my phone's there recording class. But I do remember that I want to check your flip math stuff from last week because I forgot to do that on Monday. So I just wanted to make sure that you got all that done. If you had any questions.
I think I have any major questions.
Figured probably not in here from anyone, but also I just was going to check it so that I can officially put that grade in, that you got them all done. And
Is it this thing?
Yeah. And then it goes all the way to the back.
this whole packet, yeah.
And then the last one we had to do was number 10 on the back side.
Did I ask you to check and correct these? Is that right? Or not?
No, just do
no.
them.
Just do them. Did you check them at all?
I did.
I checked the ones I could with the math 9.
Okay.
Or was that the way?
They just had the answer keys for some of them.
Yeah, that's true.
So
Yeah,
that's
they have
what
the answer
it's
keys on
used.
the website. I can't remember the answers. And some of these. Yep, I remember 10 though. B is the correct one there. Is that what you got as well?
I had C originally, but then I realized why it was.
Okay.
Or maybe it was D. I don't know. I had one of the ones that was similar, but then I went through the to the answer key and I realized, and it made sense once I.
Sounds good. There you go. Got those done. Just a couple of things to note is, so like Jonah, you were saying, and yours for several of them, you were saying like f of x equals, and then you had, what's the actual numbers? -10 plus 100 e to the -0.05 times 5.
Oh.
But this is a number, the whole thing, because there's no variables left. So when you say f of x equals this, you've told me that f of x is a constant. See what I'm saying? But what you've actually done is you plug 5 in for t, I suppose you have t. So what you have to say is f of 5 is this.
Okay.
You will lose all your points on the AP exam if you don't have that argument correct. Does that make sense though?
So anytime you plug a variable in, just make sure you have it.
Yeah, you gotta actually say like, I'm finding the value of f of 5.
Okay.
If you just had this as x, now it's correct, because you have f of x is equal to this function in terms of x. But as soon as you want to actually evaluate, make sure you actually plug that argument into both, or everywhere you see that x, or the t, or whatever you use.
I feel like most of my mistakes are just formatting stuff. Well, not most of them, but like a chunk of them.
Yep, and that happens, and you know, it's just how it goes. But we have to be like solid on notation, because notation does matter. It communicates different things to say, f of x equals and f of 5 equals. They're completely different. So assuming that somebody, because like, I know what you meant, and we did it in class, because I know you, and again, we did it together. An AP reader who's grading your test is like, does Jonah actually know that f of 5 is a specific number, or does he know that f of x is a function? I don't know, because I don't know Jonah, and I didn't do this problem with him. So they have to just assume that you don't know. And so that's why it does matter, because if you don't have like the context of other people and knowing the person who did the work and those things, then notation becomes really important. Because it communicates something about truth. And if you say f of 5 equals, or if you say f of x equals in terms of 5, it's just not true. It's not a true statement anymore. So the other thing I wanted to highlight was, Michael, in your narration, you said the example you gave was x squared
I
plus
said that
2
and then immediately thought, oh wait, that would not work.
and x squared.
Wait, was that me or Michael?
No, I used that.
That was your example, and then those will not intersect.
No, yeah, those will just stay parallel to each other.
Yeah, basically. Which is fine in one sense and not fine in another. It's not fine in the sense that you didn't define any bounds. So there is area between these, but only if there's bounds.
You could make your own bounds.
Right? So if you said like, okay, x equals -3 and x equals 5 are my bounds.
Yeah, then I could do it.
Now I've got area because I have the bounds. So it is fine to have an area between those two curves, but since you just said like, blah, 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 wherever they intersect, oh, but they don't intersect. Does that make sense?
Yeah, that makes sense.
Okay. Just want to point that out.
Dude, you and I might have the same mind, because I picked the same exact thing, but it was x plus 2 instead of x squared.
X plus 2
X
would
plus
intersect.
2 would intersect.
Not x squared though.
Right.
Because they just stay parallel.
Because those are too similar.
I like said it and then immediately second guessed myself, but I had like already gone on to the next thought, and so I just kind of was like, no, I'm pretty sure those will intersect. I questioned myself, then convinced myself in the matter of like a second.
Gotcha.
And continued.
I wanted to make it easy on myself, so I just had it straight.
Yeah, a parabola on a straight line, that's great. Those are easy to do.
It's not technically a curve though, so.
Yeah, but we just call it a curve. Like once you get into higher level mathematics now, anything that's like a linear function, we're just like, that's a curve. Like we just call it a curve because there's no point in trying to differentiate them anymore. There's just no reason to. So it's all a curve. They're all just functions. They all just have certain behaviors. So.
Mr. Martin said derivative in rhetoric, and I was like, oh, I know what that is. But it's not what you think.
That's
Scary.
fine. Yeah.
It makes me
In
think we
context
use
of what?
derivative in the wrong way in English. Like,
Not
we use
necessarily.
derivative.
Depends on what I don't know what the context
No,
is.
yeah, but like, so like, the derivative of a word, like in Latin, how we use it, like the derivative, most of the time it's meaning like the word that we get our English word from. So it's like the source, but in calculus, it's like
yeah,
the
that would
rate
be
of
a wrong
change.
use. That would be a wrong use.
Yeah.
Mhm.
So like we use it different in English and in math, which I thought was interesting.
Yeah, I don't think that would be even a correct use in English to say it that way. I mean, I'm willing to be wrong on that one, but I don't.
I think that
I
might
don't
just
think
be
that
like
would be a correct use because derivative means it comes from.
yeah.
So, or the thing that comes after. So that's why we say things like, it's a derivative of like some plant-based,
Yeah.
whatever, like in food and nutrition and stuff. They'll say like it's a derivative of this thing, and it's like because you like distilled down this thing, and so now this is the derivative product of that. So it kind of makes sense as related ideas in English as well, but yeah, good. No one uses antiderivative though, so that's too bad.
That'd be fun. I want to hear someone say that in a sentence. Just a normal.
That would be fun. Outside of math,
Yeah.
that would be fun. See if you can find a good context. That'll be a good assignment for you for Easter. See if you can think of a context. Okay, I think that was all that I wanted to touch base on. Let's get going. So we were doing area under a curve, and let's just pick up where we left off last time. So if you want to know if a polynomial is solvable or not to be able to do the area under the curve, A polynomial would be solvable if and only if, that's what this is, if and only if, its Galois group is solvable. So what is that? What is a Galois group? Probably never heard of that. A group G, we just start calling it G instead, is solvable if, one, there is normal subgroups in a chain, so G going to H and then going to H2 and so on and so forth all the way up to E. Two, all of the factor groups are abelian, and so here would be an example of the abelian groups together. And so those are the two factors for if a group G is solvable. So then you'll know a polynomial is solvable. Okay?
What?
Make sense?
No.
What part?
I'm so confused. Like, he scroll up.
Yeah. So a polynomial would be solvable.
What is solvable? What do you mean by solvable?
So like you could find a value for the x.
Oh.
What is a Galileo's group?
Galois
Galois.
group. So it's just a special kind of group that obviously Galois came up with, and so he was talking about this, and these are the two expectations if it is a Galois group. So like a polynomial is solvable if it is this group. To be that group, it has these two features.
So any polynomial, like in the context of taking its derivative, or just finding?
Just a polynomial, like any polynomial. If you want to know if it's solvable,
Okay.
it's got to be able to have a chain of subgroups like this, and then have all the factor groups
There's
are abelian.
unsolvable polynomials?
Yeah, there's lots of unsolvable polynomials. So here's more about a Galois group. So it's a group of automorphisms of the splitting field of polynomials. So that just means like the order of the Galois group equals the degree of the splitting group over the rational numbers. That's what this is, the rational numbers. The degree of the splitting field is the number of basis elements in the splitting field over the rational numbers. Okay?
Okay. Is this like a new topic, or are we still on the other thing from Monday?
What do you mean?
Did we like move on from whatever we were talking about Monday? And it just seems, how does this relate?
How can I help make it make sense more?
So basically it's solvable if you can split it and equals the degree of the split. So the degree of the splitting group, is that how many times it splits?
Yeah, kind of.
What is an automorphism?
You didn't learn about that like in algebra 2.
No.
Oh.
Maybe Michael did, I don't know.
Did you?
I don't remember any about it, to be honest.
Oh, this is my, this
Oh,
might
boy.
be why this doesn't make sense.
Okay, well here's an automorphism. So it's like the splitting field, where the bigger field where the solutions are present. That's basically what that is. So then an automorphism, an isomorphism is 1-to-1 on 2, which just means like it's a function on the splitting field that fixes everything in the original field. Yeah?
Is a splitting field the same as a slope field? Or-
No.
No. Okay. I don't know what that is either.
So like this is an automorphism because everything maps to itself, is basically what we're talking about here. Bless you. You didn't cover anything like that in algebra 2?
No.
I have never seen this in my life.
Okay.
Mr. Hattie, you have to understand that our algebra 2 days were
We're bad.
were lapse in everything. We talked about how it felt to be pregnant for like a year and a half. And
Basically.
Oh yeah, I remember hearing about that.
We had a very unfortunate time.
So like here's an example, like, okay, we factor that, and so the solutions are there. And so the splitting field would just be the solutions of that polynomial.
Oh.
Okay.
Okay, that part I can get.
Okay. So then we just have to think of it as a vector space over the rational numbers. And so then
I remember the word vector. I don't remember what it does though.
Yeah, a vector is like a direction and magnitude, essentially, or like distance. So a direction and distance.
Okay.
What is this symbol? Scholars?
This?
Scalars.
Scalars.
Okay.
Yeah, because the rational numbers are like fractions or like whole numbers, so that's like a multiplier or a scalar. You know, if I wanted to scale something up or down, I would just multiply by.
Oh,
Okay,
like
okay.
one half,
Yeah.
1/4.
Okay.
Right. So then you would be scaling it by a fourth or whatever. Yeah. So then basically you just want to have what the fewest vectors would be to generate the whole space with all the solutions. And so then.
Can you explain that sentence? Is this algebra 2? I feel stupid.
Okay, I gotta stop. This is April Fool's.
No.
I was barely holding that together.
I was so confused.
These are my old notes from abstract algebra. It has nothing to do it has nothing to do with this.
I was so confused because I was like, we were talking about one thing on Monday and then we jumped to this. I'm like,
You're like, what the heck
what is this?
I almost understand it. I'm almost there.
Every other sentence you say, I'm just like,
Vectors.
What?
That?
I do remember vectors though. That is a word I know, and I might be thinking of the character from Despicable Me, but I know the word vector. I know the word vector means something in math. I don't remember what though.
Vector had a direction he was going in now. So
Yes, but I kind of I remember the word vector from something.
That was a good April Fool's.
That was so funny to me. Just watching, you're like, what? You're like, you were trying to understand. That was great. You didn't even catch on. It's crazy. This is abstract algebra. This is like the end of abstract algebra. This is 13.
Oh, no.
So this stuff's like advanced. We spent the whole year defining what it means to be solvable, what it means to be a Galois group, or what it means to be a subgroup, the factor groups, abelian. We define all of those for like 13 weeks, and then we finally get to the whole point of abstract algebra, which is this. So this is like lots of background that you like didn't have. So there was no way you were gonna understand. So April Fools, gotcha.
That's gonna be a good one to watch back on the YouTube channel.
I'll see. We'll enjoy it.
If I ever need to raise my cholesterol really quick. Oh, this looks so much better.
Oh my goodness.
Here you go.
Oh.
All right, this is where we actually left off on Wednesday. Let's
Honestly,
pick up there.
if we went to the other thing, I probably wouldn't be surprised. Calculus at some points just doesn't make any sense, so.
Oh, it makes sense. You always get there eventually.
That, we would have probably taken more than an hour to get to the other thing.
So the other thing I just showed you?
Yeah.
Oh yeah, that would take a long time. Literally like 13 weeks to get there.
I felt stupid. Oh well.
It's okay, it was planned. I knew you wouldn't understand it.
I love how like in the background.
I asked, well, I was like, how am I gonna prank them? And I was trying to think of something, and then, cause I love pranks and I love April Fool's pranks. And so, but then I asked your sister, and I was like, what should I do? I can't think of anything good for them. And then she was like, just teach them like the most advanced thing. And you're like, come on guys, let's get it. I was like, actually, let's do that. I have old notes, I can do that. So.
There was like just enough because I've seen that Q symbol before and I've heard the word vectors. I was like, okay, I remember solving polynomials in algebra too.
When I saw the like little squiggly R thing, I was like,
No, we know that
this is
one.
not-
It's all real.
The rational,
Yeah.
the real numbers.
Yeah.
Oh.
Because we
The real
knew
numbers.
just enough of it to make it believable.
Mm-hmm. That's why I was like, oh, they know some of these words. I
Yeah.
could totally get away with this. They just won't know like abelian and isomorphic.
You see that, you're like, ah, this is gonna be hard day. It's gonna be rough.
You definitely.
All
right.
Should have been like,
Let's go to
there's a quiz on Wednesday over this concept.
I thought about it. I was like, okay, so then, anyways, let's do a quick quiz on that. Anyways,
Good.
all right, we got to do calculus. We're gonna waste our time, so let's do this. Did you guys work on it all? Or how far did you get on Monday before? Well, I mean, probably
We
copied them down.
got to.
I just copied these.
Oh, you mean the
Yeah,
notes,
these are the
not
ones
homework.
that we did in class. Yeah, I'm assuming you probably just copied it down and didn't get very far.
These, actually, the left one is almost exactly what I used for my
Yeah, it is an example.
So I could probably just do this one.
Sure, why don't actually each of you take one of them? I'd love for you each to do.
Actually, the
Why don't you just both do this one?
The right one
Just-
seems like the one we did. Though.
Just do example 5. This is like what we did with y. I want you to practice doing it with respect to y as much as we can. So you can do it with respect to x, you can do it with respect to y. So let's just do example 5 right now. Because we gotta move. So we have important examples.
Is
to get
it
to.
easier to keep it in terms, both of them in terms of y, or is it easier to have in terms of y and in terms of x?
I would put them both in terms of y because then they're easy to solve.
Okay.
Where the intersection points are. So if you rewrite this one as x equals negative y minus
Okay.
1,
Yeah.
if you rearrange that, then that way you can do negative y minus 1 equals negative y squared plus 1, and then you'll be able to find the intersection points.
I never thought I'd see the day where calculus seemed easy
Oh, so they
in
intersect there.
comparison. to
Calculus
everything else.
is so easy in comparison. People are like, oh, you teach calculus? That's crazy. I'm like, that's cakewalk.
I don't know if I should be worried or relieved.
We'll call relief for now.
I don't know.
I never did engineering classes, so I don't know how those will go, but
Wait, did you get they intersect at 0 and 1? At y equals 0 and y equals 1 is what I have currently.
There are. Wait a minute.
that should be right.
I want to make sure I don't start with the wrong thing.
Hold on. Which one are we doing?
Because it's negative y plus y squared equals. Oh, it's equals 2. Wait. Oh, yeah. No, because you have a negative.
Because this is plus 1,
Yeah, so you have to add one of both sides.
so it can't be either of those actually.
Yeah.
0, yeah, it's not 0, 1.
Plus y squared
Don't forget to graph it too.
equals 2. Negative 2 plus 2.
Do we have any
Oh,
factors?
so
Are you factoring?
2 is one of them.
Are you factoring?
It's negative y plus y squared equals 2. One of them is obviously 2.
Oh, you did it.
I'm just doing this
Oh,
way.
okay. Gotcha.
X equals negative y minus 1.
Is it possible to factor this?
Negative 1.
Yeah, should be.
Wait.
I'm seeing this one. Factoring is hard for me.
Well, it's only hard right now because you have a negative here. So just switch all of your signs, and then it'll be really easy to factor.
Negative 2 minus 1, negative 2, 0.
Yeah.
Putting that 2 minus.
What adds to negative 1 multiplies to negative 2.
Plus negative 2. Would be minus 2 y plus 1. No, other way.
Yeah.
Wait, no, that's right. That's right. Yeah, that's right. Okay. So y equals 2 and y equals negative 1. So you get one.
I had 2. I didn't find number 1 yet.
Or should I have those two? Those are your bounds.
Sense, yeah.
Negative 1, 2, and then your top one is going to be,
So
those are in terms of y equals like how we have in terms of x.
So I think it was
X equals negative y. This one's going to be a line, so this one's going to be bigger, the overflow.
Maybe. You're gonna have to graph it to see.
Well, if that's a linear line, then
Because which way does this open?
this opens down.
Not down.
Wait.
Because it's in terms of y.
Oh no, it opens to the left. Right?
Yeah.
-1.
So then this. Can I just put negative x? Would that give me the same thing? I have to rotate it.
Your calculator won't be able to do it in terms of y.
So I'll just have to rotate.
You'll just have to graph it by hand.
Graph it by hand.
Yeah.
Couldn't I just
Plug in some points and
couldn't
all
I
you need is.
Can I substitute x and then just rotate the graph? So that's it. That is in terms of y.
I graphed it by hand and I got it. Looks
Okay.
like this, which makes
Oh.
logical sense.
It's honestly easier if you guys graph it by hand than try to.
Then we can just do one of these. Honestly, solving polynomials is the hardest part for me. I think we
Pull it
skipped.
back up.
I think we skipped doing that in algebra.
It's because it's an algebra 1 concept. To be
Or
able to
algebra
factor
one,
and
yeah.
solve.
I'm just bad at it. I can do it, but I'm just bad at it.
The only things that are going through my head is like we either suck at algebra 2 or we miss something very, very critical.
+1
It's getting scary.
plus y plus 1.
So which one is the top function?
Negative y squared plus 1.
Right, because we're gonna check from right to left.
Plus y plus 2. So it'd be negative y cubed over 3.
Yep, you got it, Michael. Just finish it out.
Plus y squared over 2
Okay.
plus 2x. 2.
Okay, this is the good one. This one.
One thing to make sure you do is to include y equals on this, so that we know we're talking about y and not x. And then after that, you don't have to do it again.
Okay, the line is bigger.
Is it 47/6?
No. Just use a calculator if you want. But that's about 2 times too big, but not quite.
Is it 4.5?
Mm-hmm.
I don't know. I just messed up my arithmetic at the end.
Calculus is easy. Arithmetic is hard. What's going on my tombstone? Okay, good job. Doing it with respect to y is not too bad. You just literally do the same thing. It's just a y instead of an x.
It's just
The hardest part is trying to like doing the graphing because you have to think backwards. So, okay, we gotta keep moving. We don't have time. Find the area bounded by y equals sine x and y equals cosine x from 0 to 2pi. Okay, so this problem, think about sine x and cosine x. Think about where they intersect and just visualize those curves from 0 to 2pi. Sometimes you'll find when you do problems like these that they're going to have multiple intersection points, not just two. Don't panic. You know more than you think you know. Let's start by graphing.
Oh, you just do individual ones and you add them together?
Basically.
Mm-hmm.
Let's just graph it to get
So
started.
it's gonna go
But let's
this-
do a pretty accurate graph so we can find the actual values.
It's gonna be
So from 0 to 2pi, so that'll be pi. That'll be pi halves. That'll be, no, that's too far. 3 pi over 2. Okay, so then we'll have 1 and negative 1.
Mm-hmm.
Alright, so let's do sine.
Sine of x starts at 0.
Yep.
Okay,
And that goes
Maxes out at
up
pi
to
over 2.
1.
up to pi half. Yep.
Back
And down.
to pi.
And then down.
Yep.
And back
And
up.
up.
Alright, that's all we need. We don't need any more than that. So we can get a nice curve. And it does keep going, so if we want to include that, but okay. So there's sine x.
And cosine's gonna start up at 1.
And then
Drop
Yep.
down.
2 pi over
And
Okay.
drop down again.
Um,
Then come up.
up. And it ends up. Okay. Get a nice curve
We
going.
meet, like,
here.
Pi and a quarter.
Okay, do they meet at pi and a quarter?
I don't know, I can plug it in.
We're gonna need to know those exact values. But yes, they intersect multiple times. Here and here.
I think it is quarters.
And so we want to find this area, and 2 pi, this area. Okay? So let's reason through those intersection points. Where will those intersection points be?
At pi and a quarter.
at pi fourths.
Pi fourths?
Which you can plug in, you just do sine pi divided by 4. And then you can do cosine pi divided by 4. And they're the same number.
Yeah. Another really easy way to do it is look at your unit circle.
Oh, good point.
Wherever those coordinate points are the same, they would be intersecting right there. So what's the other intersection point?
3/4. Wait, sorry, 5/4. Pi. And
Yeah, it's going to be 5 pi fourths.
and then this is 2/4.
And then what?
2/4 is your last bound.
Sure.
Sorry, 2 pi. not
2 pi is the last bound.
Yeah.
Good. Okay, so we have those bounds. Now we just have to reason through. Okay, let me find the area of that. And then I'll add the area of that. And then I'll add the area of that. So we're going to have 3 integrals to find that area. So the first one would be the integral from 0 to pi fourths
Yep. And then,
of...
oh, it changes which one.
Good. It's going
So-
to change which one is the top function.
Cosine.
Yep.
minus sine x.
Cosine x minus sine x
So it's
dx plus the integral
from
pi fourths
to 5 pi, and this time sine is on top.
yeah, so it'll be sine x minus cosine x dx plus
Now it's swapped again. Cosine x.
5 pi fourths to 2 pi
This is gonna be a long one.
cosine x minus sine x. It is going to be a lot of writing, but it's not going to be difficult as long as we can keep track of all of our pieces. Okay? All right, what's the antiderivative of cosine x minus sine x?
Negative sine x plus cosine x.
No.
Oh, sorry, the antiderivative. Sine x plus cosine x.
Yeah. 0 to pi fourths. Okay, plus
negative cosine x plus. Oh wait, no, minus sine x.
yep. From pi fourths
Yep.
to 5 pi fourths.
Then
Plus
sine x
don't be too hard, you already did this one once.
plus cosine x dx.
Not dx. If we wanted to be
Oh,
really
yeah,
technical,
okay.
it would be plus c on all of these, but we know that they're going to cancel out when we do the definite integral. Okay, so now
Ooh.
FTC2.
Sine plus cosine pi divided by 4. Okay, so the first one's area is just 1.41.
And that's the first integral.
Yep.
Okay, plus negative cosine of 5 pi fourths minus sine. I don't want that. I want minus.
negative? Shouldn't you start with sine x plus cosine x?
Minus sine of 5 pi fourths.
Oh, you're starting at the bottom. That makes sense. Plus,
I have to start with the top bound, right?
Yeah.
Okay. And then minus the bottom bound. So negative cosine of pi fourths minus sine of pi fourths. And then that's the second integral, right?
wait,
This is the top bound minus the bottom bound.
Yep.
Okay. Plus one more. This will be the third integral.
sine x
Sine of 2 pi plus cosine 2 pi.
minus
And then that's all minus sine of 5 pi fourths
Yep.
my plus
plus
cosine of 5 pi plus.
okay, there you go. There's the whole expression. If you stopped there on the AP exam, you would get full points. You don't have to simplify.
Oh no way.
Let's simplify though for our sake.
Oh my goodness.
Got this. These are unit circle values. We can do this. Sine of pi fourths.
That'd be square root of 3 over 2.
Square root of 2 over 2. Right?
I don't know my unit circle that well.
Go find one. You gotta know for the test. Plus square root 2 over 2, because those are gonna be the same value. Minus sine of 0.
1. It's 0.
Okay? cosine of 0.
1.
1. So minus 1.
Yep.
That should say plus. Okay. Okay. Cosine of 5 pi fourths.
Um, 5 pi fourths would be. So that'd be 1/2. Oh wait, no, that'd be 1/2.
Mm-hmm. 5 pi fourths would be 1 1/4 pies.
3.
So you go all the way to 180 or pi, and then you go another quarter. So it's going to be in the third quadrant.
Oh, so it's gonna be negative 1/2.
Nope.
But in the third quadrant, isn't everything negative?
Yes.
So this is 1 pi. This would be 5 pi fourths. Oh no, it's negative square root of 2 over 2.
Yeah.
Because that's a third.
Okay, so we got negative. Oh wait, negative, so that'll just be positive square root 2.
Yep.
Alright, minus.
Sine would be also square root of 2 over 2.
So then that will just also be positive square root 2 over 2. Minus negative cosine of 5 fourths.
Negative cosine of 5 fourths is negative square root of 2 over 2.
Minus sine of 5 fourths.
Negative square root of 2 over 2. So positive square root of 2. Oh, well, I guess you can keep the out there.
Sure. I haven't distributed the negative yet. That's the second one. Third one, sine of 2 pi.
That would be 0.
Cosine 2 pi.
1.
Minus sine of 5 pi fourths cosine 5 pi fourths.
Negative square root of 2 over 2. Negative square root of 2 over 2.
Okay. There you go. There's the values. So if I've got square root 2 over 2 plus square root 2 over 2, well, that's just square root 2. Minus 1.
Yep.
Plus square root 2 over 2. Minus
Square root of 2.
square root 2 over 2, right? Well, no, this would be plus square root 2 over 2.
Well, square root of 2, not square root of 2 over 2.
You're right. Okay. Right, and then plus
1.
1. Plus 1. That was that. Close that parentheses. And then that'll be
Minus square root of 2. Oh, plus square root of 2, actually.
plus square root 2. Alright, hey, this is getting better and better. Looks like I could drop parentheses at this point.
We know that 4 times square root of 2 is 2. Wait, no.
No.
2, sorry, 2.
But I have 4 square root 2's,
So that means it's 4.
and then 1, minus 1 plus 1, those cancel. So I just have 4 square root 2. Yeah. That can't be simplified because the only way to simplify the square root is to square 2. Right?
Oh, not multiply, yeah.
Okay. Whew, there you go. So the area under the curve between sine and cosine from 0 to 2 pi is 4 times the square root of 2. Now you have the exact area.
Huh.
Crazy.
That's not gonna be on the AP exam, is it?
That's about as hard as it can get, but just because it's long, it's not even hard. You just have to know unit circle values, right? Make sense?
Yeah.
Okay, that is what we had to get through. Okay, good job. Tomorrow, there are some foot math videos to watch, and if you want to print the notes to do yourself, I'm not requiring you to like do the notes because you've already got notes from the class. But he goes over some really helpful examples that I think are really important that I want you to see, and since we don't have Friday this week, I don't have time to teach them to you, so he just has some really good examples. So he'll do over with respect to y.
Isn't it both? I thought it's both. Yeah.
Those are you have to, and then I've posted it as optional so that you can watch the one with respect to x, but you're gonna be fine. So you don't have to watch that one. The other thing is Tuesday next week, I have to do something to do. So 8 through 13 out of the skill builders do that Tuesday. I don't care if you
I love it. It gives me life.
I'll probably do that and then work on my project.
Just gotta get done by next Wednesday, and I'll collect the skill builder packet to grade. We stop that.
Were they fooled?